Hello everyone. Just updating. I was surfing YouTube and came across this video on reflection and refraction of colored light in water and air surface too. I thought it was pretty interesting. I wanted to show y'all and explain to you what's going on. So this guy is filling up um, this tank, and if you see here how the blue light is bending more than the yellow light, more than the red light, and more than the white light. This is due to a concept called refraction. Refraction um, is basically the change of direction of light due to speed increase or speed decrease when going from one medium to another. Water being the first medium, and air being the second. Now, if you notice here, as you go through air, it's a lot easier, and with less resistance, you can go faster. Water or a liquid, which is more dense than the air, would be harder to go through, so you would imagine going through it a lot slower. So you have this speed. This can be considered a velocity. And since you're going from slow to faster, the angle of refraction is going to be away from the normal line. And when I say normal line, I'm referring to a line that you would draw perpendicular to the point of interaction. So right where this beam of light touches the surface of water, and then perpendicular from the surface of the water, would be called the normal line. And if you're going from a slower or a denser medium to a less denser medium, it'll be considered faster in the air. So in that way, would be considered to move away the angle from the normal line. Now, similarly, we can pretend that this light source is coming from out here somewhere, and it's coming from a faster, still the same point, normal point, and as soon as it hits the water, it slows down, and the angle of incidence is closer to the normal line because we're going from a faster to a slower. So in summary, if light goes from one medium to another, or from slow to fast, it'll move away from the normal line. If light goes from one medium to another, so from fast to slow, then the angle of incidence will get closer to the normal line. And right here is reflection. Reflection basically says that light coming in, the angle of incidence will equal the angle of reflection. And if you look here, it looks like these two angles are the same. And so light is being reflected in these aspects and refracted in these. And see what happens when he moves the wheel. Notice how as light becomes more perpendicular to the surface of the water, that there is 0 degrees in angle of reflection or refraction. The reason why it reflects instead of leaves the surface is due to an idea called critical angle. Cool, huh? Anyways, just wanted to show y'all a perfect example of reflection and refraction. Thank you for watching.